All right, happy Tuesday. How's everyone doing? Yeah, great. Good to hear it. It's nice to be with all of you. We have a really good one for today. We're introducing time series. So we're going to talk about relationships through time. And then next class, we're going to start talking about panel data, which is one of the more, I think, interesting data structures. So we're going to review a bit about data structures here at the beginning before we get into time series. And then we're going to do some visualizations. So I'm going to show you some bad visualizations for thinking about data sets with the time component. And then we're going to get into some graphing. So we're going to talk about line plots and thinking about seasonality. So that's what we're going for today. You hopefully saw my announcement about the first mini exam. I scheduled it for September 22nd. So that's not next week, but the week after. So that'll be the Tuesday in 2 weeks from today. And that'll give us plenty of time to get through part one with plenty of time for practice and a bit of review of the general scope for what we've done in part one. And then once we get through part one, we'll take the mini exam, and then we will start in part two. So we'll start working with data structures in different ways. Okay, so that's mini exam. Let's see, homework 1.3 is posted. 1.4, I just checked right before class. The link is broken, so I'm gonna have to go back and fix that. But that'll get posted later today. These, as always, homework 1.3 and 1.4 are just going to be directly on the topics we cover in class. So part 1.3 and 1.4. So the match, as always, is going to be exactly 1-to-1. Let's see. So any housekeeping, anything I've missed, any questions you might have? You all feeling a little more comfortable with visualizations than at the very beginning of the semester? How'd the last homework go for you? Okay. Actually, can I get a raise of hands? How many of you answered the questions? I'll be able to see this when I go through the assignments, but I'm just curious. How many of you answered the visualizations using Python? And how many used Excel? Okay, about 50-50 split. That seems about right. You can answer any of these questions in the homework when we talk about visualizations or any other type of data work. In parts 1 and 2, feel free to be working with either Excel or Python. They're really identical tool sets in a lot of ways. Like the things we're doing, we are doing in the same ways in Python and Excel. Python just gives us a little bit of an extra sort of reproducibility, and it's a systematic way of doing the same things that we do in Excel, just with code. And it will also allow us to run statistical tools once we start hitting part 3, part 4, and part 5. So eventually we will be turning our attention almost entirely to Python for those statistical tools. But a lot of people actually use Excel alongside Python and use both tools. So that's definitely a way you can work with data. This is a shot from the weekend. We went on a walk and we both had sunglasses on. All right, did I mention I had a child this summer? Okay, so this is where we're going today. We're going to do a bit of review on data structures at the beginning here, and then we'll do sort of a warm-up exercise, and then we're going to start working directly with time series data. Okay, so you'll remember this from the very beginning of the semester. We were introducing the dimensions of data. So we talked about different variable types, categorical and numerical primarily. And then we also talked about the number of variables we have in our data sets. And so far what we've covered in part one is univariate data. So data where there's one meaningful variable. We also talked about data structures. So we said there were generally three main types of data structures. And these are the three. We've spent the semester so far talking about cross-sectional data. So this is like the survey that we gave at the very beginning, which is like, I just look out into the world, I see a snapshot of things at a particular time, and then I can look across people or across entities, so like across states or across countries at one point in time. This is our cross-sectional data. So like household income in a particular year would be an example of that. Today, we're turning our attention from cross-section to time series. So time series data is a little bit different. Instead of thinking about one snapshot in time, we're thinking about one entity through many periods of time. So what we're going to look at for most of class today is prices. So the prices in one market for coffee, essentially. And this is multiple snapshots through time, but of one entity. So we're looking at one thing repeatedly through time. So the variability is instead of it with cross-section, the variability is not across observations, but across time. And then panel data is sort of the combination of these two things. So we have in panel data, as you'll see, maybe next class, with panel data, we're looking at many observations through many periods of time. So it's sort of combining the variability in cross-section with the variability in time series. So an example of panel data would be something like household income over time. So if we have many observations, many households, and we see each household at many periods through time. Okay, so I've given some examples here which may give away some of the answers to the first exercise, but this is sort of how we think about data structures. We spent most of the semester so far talking about cross-section. We're about to talk about time series, and then soon after we'll talk about panel. And then geographic is just a different type of thing entirely. Okay, so we have three data sets here, and we're going to jump into the exercise just right off the bat. Once we get through classifying data structures, we're then going to actually start working with time series and think about best practices for summarization and visualization of time series data. All right, so you can hop over to the notebook. Still haven't watched the movie this semester. I've also gone ahead and posted some notes. I think this link works. So if you want to take a look at the notes that I use sometimes for preparing for the class, these are just some things I've written up, and you can take a look at those if you like. I haven't posted them in past semesters, so let me know what you think. Okay, so we're going to work with time series data. You can click on the link here, which will bring up the notebook. And you can also download the data sets directly if you like. So we can just download them. So the first data set we'll work with is this household income data. So I'm going to open this in Python. So we're just gonna run the imports and then the file path. And then what we could do is just plot the data set directly. So if you wanted to in Python, this is the way I would do it if I was working with a notebook like this. We have the data set here directly. If you want to do this in Excel, you can download the household income data set with the link I gave on the website, and we can look at what's contained in the data set. Okay, so our goal here, just as a bit of a warm-up, is to try to classify what data structure this is. So we know there's an income variable which is numerical, but we know some of the and then we have household income and year. Household income would be categorical. So we have our variable types classified, but what we want is to choose one of the three data structures: cross-section, time series, or panel. And we're gonna try to classify this. So open the data set up, take a look at it, and then I want you to tell your neighbor what you think the data structure is. We'll take about a minute for this. And then I'll ask someone to give me a wrong answer in a second. All right. If you're still trying to classify this, keep going. You can always talk in class. Like if you have questions with someone else about the material in class, I strongly just keep talking to each other. That's great. Just turn the volume down a little bit so we can focus on what we're covering. But feel free to keep talking. Someone tell me what data type this is, and I'm looking for, data structure. I'm looking for wrong answers. What is this? What's the data structure? Is it Luke?
Yes. You want a wrong answer.
I'm looking for a wrong answer.
It's a time series.
Okay, so why is this a time series?
Well, a time series is multiple times, but it's one movement.
Okay. So
this is hard because I just want to get the right answer.
Yeah, so correct. You are correctly incorrect. It is not time series. Someone give me a correct answer. Luke answered the question correctly, but also incorrectly. Yeah. Panel. And why is it panel?
I don't really know, but that's just what the example is on the slides.
Ah, so using the slides. Someone other than Luke, and remind me of your name?
Alexis.
Alexis, that's right. Someone other than Alexis and Luke, tell me why this is panel. Okay, nice. So we have multiple time periods. So in some sense, Luke was correct. There is a time component to it, and you can see that even with year. But we also have multiple households. So you can see there's household 1, so H001, and you can see there are multiple observations for the same household through time. So you can see their income as it changes. But then we also see a second household at another point in time. So we have multiple households being observed through time, and we have one variable that we're tracking. So both cross-section, so multiple households, and time series, multiple periods of time. So this is panel. Okay, any questions here? Next class, we're going to think about methods for summarizing panel data. It's obviously the most complicated of the three. What about this one? So the second data set is household savings. So you can download this if you like, or you can load it in the notebook. Let's take a minute here, try to classify this, and then I'm going to look for not just a wrong answer, but also a justification for why your wrong answer is correct. Okay.
Doing this. Because I just
Can I
loaded
exit
this.
this?
Yeah, you can do whatever you need to do. Because I just loaded it the way that like in the notebook, and then I was trying to figure it out, and I was like, why is it like this?
Yeah, I've never seen that before. Let's restart. Okay. Nice.
Okay.
Should be all set. Okay. Someone tell me incorrectly what the data structure is. Someone other than Luke. Yeah.
Is it a wrong answer or?
I'm looking for wrong answers only.
Okay. Time data, time series.
Time series? And why is this time series? That's a really tough question to answer. You could say this is time series because there are multiple periods of time in this data set. Incorrectly. Remind me of your name?
Joe.
Very nice, Joe. Someone give me a right answer now. Ruby.
I think it's cross-sectional.
Okay. And why is it cross-section?
We only have several households, but we only have the savings at a certain period of time.
Yeah, nice. So we have one sort of snapshot of many people. And we can see this, just as Ruby is saying. I say saying and write savings at the same time is complicated. So we have multiple households, and no household repeats, it looks like. And then we have a savings rate. So it's just really an observation across many individuals, and it looks like it's one period of time. Okay, yeah, so this is cross-section. And then we're going to do the last one. So you can use deduction to figure out which one this is. But let's actually just look at it and try to figure it out if we hadn't already looked at two others. So the last one is monthly copy prices. We'll take about a minute here. I want you to take a look at this data set and then try to classify it. And then I'm going to look for a correct answer, strangely. Go. Okay, someone tell me what data structure is this? Yes, is it Sophia?
Time series.
Time series. And why is it time series?
Because it follows the same type of copy over and over.
Nice. So, so what we can see here is we have multiple dates and one variable, price, that we track across time. So the dimension of variation is time. So we call this time series. Okay, any questions here? So today we're going to spend essentially the rest of class talking about time series, and we're going to get familiar with best practices for thinking about how to set up a time series. This will probably feel very intuitive, and then we're going to talk about different ways of looking at the series itself in more detail. So we're going to work with this coffee prices data set. If you're thinking about, if you look at the data set, you've already loaded it, and you're thinking about how you set prices in January, let's say, of this year. This is a data set that has information about historical prices, but it doesn't give us a prediction about the future. If you're thinking about how to use this data set to inform your decision about how to set prices in January, one thing, at least historically in this class we've done, is take a numerical variable and summarize it using a histogram. So what I'm going to do first is just create a histogram of all of the prices in our data set. So if you wanted to do this in Python, you could just write out, sns.histplot data, and then the x variable would just be the price. And that would give us a figure that looks like this. If we're thinking about how to set prices in January of 2026, how would we use this? If you saw this, what would you do when you're setting your price in the future? Yeah.
I would use the data from year 2025 and try and price my coffee competitive to where I could sell it off.
Okay, so we have to think about sort of the more recent data, right? Like, so instead of looking at the entire historical trend, or the distribution of prices going back to the 70s, we want to do something about more recent data, right? Remind me of your name?
Joe.
So Joe is saying, I think sort of implicitly, like, this may not be the right visualization tool to answer our question. We can't tell what's most recent. There's lots of data in this histogram that just probably isn't useful to us. And it's really essentially impossible to see using a histogram. So a histogram in a lot of cases is very powerful, but when we're talking about a time series, a histogram actually sort of obscures some of the most important components of the data. What Joe's recommending is we look at the most recent data. So anyone know how we do this? How do we set up something that tells us what's most recent? What if we take each individual data point, place price on the vertical axis, and then place date on the horizontal axis? So we're just going to plot a bunch of points and plot them against time. So maybe this actually is sort of in line with what Joe's recommending. Let's think about the most recent data. What do y'all think of this figure? Do you like it? How many of you think this is more informative than the last one? Yeah, I agree. And how many of you think we can improve it? Yeah, I agree with that. I think we can probably improve this. Any suggestions for what we might do? Yeah.
Maybe like a line of best fit.
Okay, so one thing, and we're going to talk about this actually quite a bit starting in part 3. We haven't really talked about lines of best fit yet. We will. But what a line of best fit would do is just draw a line through the data points, minimizing the difference between the line and the data points directly. And we will get there. Remember your name? Chase. What's before we start talking about statistical tools, what's a thing we could maybe do to improve this figure? Yeah.
We like clump a bunch of them that are relatively like near each other to maybe like a paragraph or something.
Okay, and we're actually going to do something very similar to this later in the class period. The idea is maybe we'll try to, there's a lot of variability here. There's a lot going on. And maybe what we'll try to do is try to summarize different regions of the graph. And then maybe use bars or something else. I'm going to actually recommend a box plot for that kind of tool. When we use a scatter plot like this, where we plot each individual observation at a specific point in time, we're sort of subconsciously seeing each individual observation as a separate entity. So when we plot dots like this, it looks like each one of these prices is separate. One thing we can do to improve this figure is communicate to whoever the audience is that these are actually repeated observations through time. So they're essentially connected. They're the same observation, but through time. And one thing we could do with this is create a line. A line graph is the main time series tool that we're going to work with. How many of you like this one better? Yeah. How many of you like this worse? How many of you like this better? I think a line graph actually communicates much more clearly the main point of time series, which is that we have repeated observations. So it's the same unit of measure through time. So it's essentially connecting points together to tell us that these are one connected thing we're measuring. Okay, and I think this also communicates what Joe was saying, which is when we're thinking about how to set prices in 2026, we want to look at the most recent data. This is 2021, so maybe this would be a different year. But when we're thinking about how to set prices in the near future, we want to use the most recent data. So there's some important component to the time. So more recent data is more interesting, more useful to us. So my next question is, do you notice a trend? So sort of a pattern through time. Anyone want to summarize this? Is it Chase? No. Yeah. Remind me of your name. Jason.
There's more like a positive relationship.
Okay. And how do we see that there's a positive relationship?
The line is steadily increasing throughout the whole year.
Yeah. So Jason's saying, look, as time progresses on the horizontal axis, we see an upward movement in prices. And this looks pretty consistent, right? So we start off in January, and then we see a general upward, what we call a trend. So we see a generally positive trend here. Although you can see there's variability, right? Up and down movements within a larger trend. Any other observations here? Yeah.
I don't know if this correlates to the trending price, but you can kind of see that as it's going up, that's
Okay.
is typically when things like that would spike.
Yeah. So you're pointing out like these little jumps?
Yeah, once you start getting into like the later months,
Uh-huh.
you kind of see a jump, which is also like fourth quarter for a lot of companies, which could contribute to higher prices.
So this little area here.
Yeah.
Okay. Yeah, so like November we start entering, at least in the US, we start entering like our main holiday season. And also, I don't know about you, in the winter I drink more coffee than in the summer. It's darker, maybe it's nicer. So maybe as demand rises, so does price. Yeah, so interesting observation. And we're actually going to talk more about seasonality in a second. Remind me of your name?
Sophia.
Two Sophias. All right. Okay, so yeah, so we can see a general trend, generally positive this year. But one thing we often want to do is get as broad a picture as possible. So one thing we can do with the time series is not just look at specific intervals, but try to look at the entire range. So I'm just going to zoom out to 2000. So what I've done here is plot all of the coffee prices between 2000 and 2025, so roughly today. I guess it was the end of last year. And what do you notice here? Where does our previous figure fit into this graph? So just 2021. What are some general things you notice with this interval? Ruby.
2020 to like 2022 or 3 there was a really sharp increase.
Yeah.
And then again
Yeah, so right around here we saw a massive increase in the price of coffee, which happens to correspond with the previous figure, right? So this was only the year 2021. We went from $1.25, basically doubling the price of coffee, to $2.50 during that time. And you can see that corresponds with basically starting here, jumping all the way up to $2.50. So our narrow focus actually happened to capture something pretty extreme. Anyone have a theory for why prices jumped during that time? Anything else going on in the world in 2021? Yeah. COVID, yeah. So like supply chain disruptions, lots of things got more expensive simply because supply was way lower. Okay, so we have subtrends. We plotted one of them earlier, but you can see other periods here. So like this was right after the recession. Do you notice a general trend here? Like over this longer period? I don't know. It's maybe slightly upward. It starts off, around $1 and then maybe ends, $1.50 to $2. But it's not quite as striking or as clear a pattern as we saw when we just looked at one year. So we saw many periods of increase. We also saw many periods of decrease. One thing we can do if we're trying to communicate not just the general trend, but also subtrends within a larger pattern, we can try to communicate that visually. You may have seen figures like this when we talk about recessions. So you'll see like GDP through time, and then during long periods of decline in GDP, often you'll see figures that look like this, showing in gray bars periods of recession. What I've done here is just color the background at the quarters where we see declines in the price of coffee. I've just colored them gray. And I think this actually communicates not just the time series, but it also highlights something extra about the patterns that we see in time series. So I think this is interesting. We don't do a lot of this background shading, but I think when you're trying to communicate, sometimes this extra bit of information that we set behind the line graph can be useful. It's a little bit harder to construct, but it's definitely something that you can do. Okay, any questions here? So the main points: time series is data connected through time. So when we try to communicate with a figure, when we try to communicate time series, we want to indicate to our audience that this is one sequence of data, one repeated measure through time. And the way we do that is by plotting on the horizontal axis of time, we plot a line, indicating to our audience that it's one repeated sequence. It's one consistent thing we're measuring. And we like to plot against a time series horizontal, against time, to indicate to our audience what's first and what's last, so the sequence itself. All right, so what we're gonna do is actually construct a line graph in Excel and in Python. So we're gonna do both. For this one, it turns out Python is just way easier, but we can do a line graph, a time series figure, both in Excel and Python. So what you can do is run over here. So if you've already downloaded coffee prices, you can just load that. And just like with all of our exercises in class, you want to keep things organized. So we have our folder. I'm keeping this on the desktop, but for today, we're going to call this part 1.3. So we have a nice subfolder. Let's keep this organized. And then in the subfolder, we're going to take the monthly coffee prices and just drag it in. I'm going to rename this just so it's nice. And then we can open this. So the first thing we're going to do is create a line graph in Excel, and then we're going to do the same thing in Python. Okay. So first thing to do is to save as, so we don't lose our figure when we create it. All right. How many of you are set up with your file system, your part 1.3? Hands for that. That is not the rousing support I'm looking for. Y'all ready for an exercise? It's good to talk about the concepts, right? Like, we need to think about why we're doing the things that we're doing. There are lots of choices we make when we work with data, but a big part of what it takes to actually be good at this stuff is just lots and lots of practice. So we're going to practice creating a line graph. Anyone know the first step here? What do we do to create a line graph? Yeah.
I can guess.
Let's guess.
Would you highlight the two columns and then go to insert?
So this is a great guess. It turns out to be not quite right. Funny enough. Remind me of your name? Matan. So Matan was saying, let's highlight the date and the prices, which if you were just jumping into Excel, that's what I would do first. In fact, when constructing this exercise, that's what I did. Turns out you can't do it very easily that way. The way to do it is to just select price. Date is already in sequence. So we're going to select just price. We're going to go to insert. And I think very similar to Matan's recommendation, we're just going to create a line graph with simply price without the date. So I'm going to click on this, and it'll create a line graph. Pretty nice. So we have price, and we can see it's a line, so it's definitely showing us the entire sequence, and it's showing us the repeated observations connected through time with the line. And we can just change the title here, call this maybe coffee price, and maybe we'll leave it there for now. Just call this coffee prices. What's wrong with this figure? Yeah.
The X, it's just like way too confusing.
Yeah. I mean, when does the data start? I can't tell from this figure. When does the data end? Also can't tell. The horizontal axis, as we've constructed it, is meaningless. It just gives us the sequence. Remind me of your name?
Matt.
So Matt is saying, let's make the horizontal axis better. It turns out Excel just doesn't have a nice way of making a line graph, a time series, straight out of the box. What we have to do is double click on the horizontal axis to give us some options, unfortunately. So all I'm going to do is just double click on, I'm going to right click on the horizontal axis. And there's this this select data option when you right click on the horizontal axis. So we'll just select that, and it brings up these options. Unfortunately, we have to do all this, as far as I know, to create a line graph. A time series. You'll drop down here, you'll see horizontal category axis labels. So all we have to do is select this, which then is asking for how to label the horizontal axis, and then we select the date column. And then I hit enter, hit OK, and then we have dates. Okay, any questions here? Luke.
That again, I'm not seeing it.
So Luke's wanting me to do this again. So what I'm going to do is right-click on the axis, select data. How many of you are there? Oh, hands higher. I need to know. Okay. And then we're going to select data, which gives us this option. We don't want another line. What we want is to label the horizontal axis. And I'm just really surprised how complicated Excel makes this. But we're just going to select data source.
Is the
Are you not seeing that?
you're getting is not the same as well.
Maybe it's different on Windows.
Yeah,
Mine has the same either.
yeah.
And you're not seeing an option for selecting.
But it's like there's an edit column where you can just edit the category.
Okay.
What I did was I just clicked edit, and then I clicked these things. I just clicked date.
So there's apparently, I'm not familiar how to work with Excel on Windows, but I guess there's an edit option for the axis.
Yeah, it says axis label.
You just hit
And then, yeah, you just add B. So if you're on Windows and you're having some trouble here, reach out to someone next to you. And this is one of those cases where it's good to be talking to the people around you. So if you figured it out, help someone out next to you. And if you need help, have someone help you.
Okay, thank you. Appreciate it.
And then you can resize this. There are lots of ways to continue. Lots of ways to continue sort of playing around with the axis labels. It still doesn't look great by default for some reason, but this is at least a way of doing a bit of time series visualization in Python. Any other questions here? Thankfully, we don't have to mess around with Excel forever. Python is much simpler for these kinds of things. So I'm going to save this. This is a reasonable figure, but it's not great. In fact, the date is the first axis label. Lots of things we could improve here. We've at least gotten in the ballpark of a nice time series figure. But I'm going to exit out of this. And then I'm going to hop over to our exercises. So we have our coffee prices data set. What I want to do is plot this as a time series. Seaborn, our main visualization package, makes this very easy. Anyone have a guess about what we write? Yeah, Chase? Joe, I'm sorry. Yeah.
It would be SNS.line plot.
SNS.line plot. And then what will we do next?
We'll put in our X and Y features.
Okay, so I'm going to put in the price data first. And then our X, let's use, so we have prices. I'm going to use the date column. So we'll use date. And then someone else, what would we use for Y? Our vertical axis? Yeah, the price. Yeah, so we'll just use Y is equal to price. All right, and we'll run this. And I think this is a much nicer figure. It gives us pretty nice horizontal labels for time. So we don't see a lot of individual months on the horizontal axis. There are things we could definitely do to improve this figure. What would be something we could do to make this figure better? Should we add a title? So what we're going to do is just define a title. So Seaborn doesn't give us a title option. We use matplotlib. So we've already imported matplotlib as PLT. So we're just going to use that. Just like my favorite joke. My friends in college called me Little Tay. We're going to call matplotlib PLT. So PLT and then title. I'm just going to say coffee prices. And then that'll add a title. So we're just programmatically defining what we want the figure to spit out for us. Lots of other little things we can do here. You want to hear another nickname? My friends called me Tay-Tay, which unfortunately got co-opted by another tailor who maybe more people have heard of. Right? Tay-Tay? Yeah. Maybe? I guess you just got engaged. Okay, so nice figure. Any questions about this? Some other things I might do, you don't have to make your figures wonderfully beautiful to be good at effectively communicating what you're trying to communicate. But some other things I might do, you can take out date and price, I think. We already know that the horizontal axis is date, so in some sense, date is just redundant. And in the interest of making our figures as simple as possible while still communicating everything, I would probably take out date. So we could write plt.x label, and then just tell it to not say anything on the x label. If we run this, it'll take out date on the horizontal. I do this a lot, actually. And then I think price is also pretty clear on the vertical axis. although this one's a little bit more controversial. So we can say plt.y label, and then take that out. We've already said that we're talking about prices. But those are more controversial, I would say, especially the last one. So that's up to you. Any questions here? Nice. So lots of things we can do with our figures, lots of little like operations we can perform to make our figures better, but this is the basics of a good time series figure. On the horizontal axis, we want time. Vertical axis, we want the price or the value that we're measuring, and then we want those points connected through time with a line. All right. So this is relationships through time. This is often really useful when we're thinking about, how to set prices next month. We want to particularly focus on the most recent data, and a line graph allows us to see what that data is. The most recent is more important, and so it allows us to sort of identify what's most important. But let's see, Sophia mentioned the possibility of seasonality. What if, in addition to the most recent data, what if there were trends that were consistent through time, but at different points in the calendar? It's a little bit hard to see that kind of thing from a figure like this. We've highlighted, some points of decline, so maybe there's you're able to see some patterns here. But in general, we can have subtrends, just like we're seeing, where we have periods of decline, subtrends within a larger trend. And sometimes those trends are specific to seasons. So what we're going to do next is talk about the possibility of seasonality. So maybe prices are higher or lower in different months. So you'll remember the familiar box and strip plot. We just have the horizontal axis with coffee prices, and then we summarize the quartiles using a box. This makes it very easy to read some of the main components of the distribution just very easily. With our box plot. So you'll remember the bottom whisker is just the minimum, the middle part of the box is the median, and then the upper whisker is the maximum. And so on top of the box plot, I often like to include this strip plot. But I'm actually going to take out the strip plot and show us just all of the months all at once. So this is what we call a multi-box plot. So we have box plots showing the distribution of prices across different months. So it's in January, we're just going to look at all of the prices that happen in January and show the distribution just in January. And then in February, we're going to show just the distribution in February. So we've essentially taken out the sequence, right? So it's no longer in sequence through time. But what we've done is break out the seasons and show the distributions within each one of the seasons. And this gives us another perspective on the data. Sometimes the seasonality will be much more clear. But even with a data set like this, where we go back all the way to 1973, we can still see some patterns. So if I were to ask you, we've just looked at the overall trend. Are there subtrends? Like, is there some seasonal component to prices? If you're looking at this, what might you say? Yeah.
Not really.
Yeah, it doesn't look like there's a whole lot of seasonal variability here. What else? There might be a little bit. So let's maybe look at a few things just to see maybe some sub-patterns. But I think the general pattern, remind me of your name? Luke.
Yeah.
So Luke, I think Luke's general conclusion here is pretty sound. When we're simply looking at like measure of average, I think there's very little variability. And we're gonna zoom in on this a little bit later. Very little variability by season. Not a lot of seasonal pattern to prices. But I want to be a little more specific before we get there. So let's ask maybe some sub-questions. In which month was the highest price recorded? Yeah, lots of hands. Yeah. April. And why are we saying April?
Because that's where kind of the maximum is for the line.
Nice. So we're looking at we're able to see this because we have box plots. We look at the upper whisker across all of the months, and we can see that April has the highest upper whisker, so April has the highest maximum price. Remind me of your name?
I'm Kyle.
Kyle. So Kyle is using the fact that box plots visualize the quartiles to be able to answer this kind of question. Any questions here? What about this question? What season are prices most spread out? Yeah.
Probably like spring, like March or May.
Okay. And how are we noticing that spring has the most variability?
So like
Yeah, nice. So maybe we look at ranges, and then we try to find which general season has the largest difference between the upper and lower whisker. Remind me of your name?
Jason.
Second time I asked you for your name, I guess. So you can quiz me on your names. I think I'm not getting a passing grade at the moment. So Jason's saying we're going to look at the ranges, and then we identify which range or which general season has the largest range. And I would say generally that's like spring. Yeah. Any questions here? So this multi-box plot gives us some extra information about the possibility of seasonal variability. Like, are there patterns by season? What about this question? Which I think goes back potentially to Luke's earlier observation. Is there a trend here? Yeah, Alexis.
It's like around $1.25 a cup.
Yeah, pretty stable. So the middle price through time seems to be pretty consistent. It's a little bit hard to see here, but one thing we could do is take each of the quartiles. So I'm going to take each of the lower whiskers, the median, and then the maximum. I'm going to ignore the Q1 and Q3, and then just plot these three, the minimum, median, and maximum, as line graphs. So I have 3 lines, minimum, median, and maximum, which allows us to see sort of the time variability of these quartiles. So is there variability through time in this way? And I think this is maybe another picture that allows us to see. I mean, first off, the maximums seem to all happen in the spring. And then you can also see minimum and median just don't seem to change that much. They seem to be very flat, at least on this scale. But one thing we can do here is zoom in even further. So if we change the vertical axis scale and we just plot the medians, you can ask maybe more subtle questions. It doesn't seem like there's a lot of variability here. But one thing we could do is just ask this kind of question. So maybe take a second here, like 15 seconds to find like a general number for this question. We're looking for the difference between the largest and the smallest medium price per pound. Anyone have a number? Yeah. Around 0.1. Yeah, something like that. So you can see the minimum, and maybe I didn't do a good job of labeling this, but this is like maybe 1.21, and then maybe the upper is around here, so maybe 1.0, 1.30, which I'd say maybe a little closer to 0.09, but yeah, generally right around 0.1. Yeah, very nice. Remind me of your name. James. If you quiz me on your names at the moment, I'm sorry to say I'd really struggle. Thanks for the answer, James. Okay. Any questions about this? So what we've done, right, we have the basic line graph, which gives us the general sense through time, gives us longer term trends. But sometimes we care about sub-periods within a longer time series. And so one thing we can do, just as we've done here, is try to pull out seasonal variation by looking at months. And we can do that pretty easily using multi-box plots. Sometimes, like with the medians, the variability in the median itself is not very large. And so to zoom in on that specific quartile, one thing we could do is just plot those quartiles directly as a line graph. And that gives us maybe a more subtle perspective on the variability of a statistical measure through time. Okay, so depending on your question, if you were wondering what's the difference between the median and the minimum and maximum median across months, this is how you would maybe try to answer that question. It'd be difficult with a line graph, and it would be difficult just looking at the box plots themselves. So, as always, one of the big conclusions here is that we want to match the visualization tool to the question and the data. So what's the question we're trying to ask of the data? Let's use the right visualization tool for our purposes. All right, any questions before we jump into this? So the last thing we're doing today is constructing a multi-period box plot. And we're gonna do this with both Excel and Python. So this is just a bit of that summary I just mentioned. Line graph is good for numerical variables through time. We can highlight sub intervals using shading, and then we can use the multi-period box plot to show the distribution. So let's jump back to the coffee prices data set, which unfortunately I closed, but we can open this back up. Actually, for the sake of time, we can do this in Python. There's another step we have to do. I'm sorry, in Excel. But what I want to do is, for the sake of time, let's do this in Python, and then I'll explain how we do it in Excel a little bit later. Okay, so we have our data set up here, which is just prices. And then what we want on the, right, we want the, you can do this in a couple of ways. The vertical axis, the way I have it set up in the slides is with month on the vertical axis. And then the distribution within the box plot is on the horizontal axis. But I'll show you, we can do this either way. We can sort of flip it so the boxes are oriented vertically if we prefer. As you'd expect, this is pretty simple to do. So if we're thinking about how to construct seaborne figures, the place we start is just S and S. And then we want a box plot. It's a multi-box plot, but we just write it as box plot by default. So this is box plot. We have prices, and then I want my preference is to put the categories on the vertical axis. So I'm going to use Y for month, and then I'm going to use X for price. So my X variable, the horizontal axis, is price, and then the vertical axis is a month. And when I do that, I get a figure that looks like this. I don't like having outliers in the data. What I like to do is include all of the data points in the distribution itself. I think it's a little bit funny that by default there are outliers. In general, we like to include all of the data points, at least by default, within our distribution. It's part of the distribution, and so we want to describe it that way. So what I'm going to do is specify that I want the whiskers to contain every data point from the 0th quartile, percentile, all the way up to the 100th. So I'm going to say whiskers, and then we want the range from 0 to 100. And when I run this gives us the box plot that we were hoping for. Okay, any questions here? So we can do this also in Excel. And I think let me just talk through how we do this. We don't have a month. We can construct a month from the year. This is a little more challenging to do in Excel. So this is going to take a little bit longer than we have class time for, but let me show you how we would do it if we had a month column. So if you had month, and then we had, like this is August, and then September. If we had that column, Excel actually has a built-in box plot feature. And maybe I'll fix this and bring it into class next time. But you go into statistical, and then there's a built-in box and whisker plot that actually gives you multiple box plots, and you can use that by category. But unfortunately, it looks like I didn't include the month here, so we'll have to do that next time. Okay, how many of you were able to create the multi-box plot? Okay, and if you weren't able to, now's a good chance to check with someone next to you about how to do that in your own code. All right. So before we go, can I get a poll? How many of you think creating figures is easier in Python? And how many of you think creating figures is easier in Excel? Yeah, we don't have to agree. But I agree with most of you. I think visualizing data sets is much simpler in Seaborn in Python than it is in Excel. What we've done today is focus on relationships through time. We've talked about the general trends that we can see using time series. We don't typically summarize time series variables using a histogram because we care about the sequence. We want to know where in the sequence each data point is. Then we also care about subtrends. And so one way we can visualize subtrends is using shading, but the main tool is using multi-box plots. This is time series. This adds another dimension of variability to our data. Next time, we're going to talk about variability across individuals and through time. So we're going to talk about panel data by looking at, can you guess coffee? Okay, that was supposed to be funny. I'm going to have to work on my jokes for next time. Stick around if you have questions about the homework. Homework 1.3 is posted, and 1.4 will be posted pretty soon. 1 second.